we're going to continue this session with our third session of the day. And that session is enhancing continuity of operations plans with hurricanes and flood data. So it's all part of this extreme weather track. You're in session 3. We're trying to keep it on time for you as much as possible. And this session really is focusing on 4 panelists. We have 4 panelists. In this panel, we'll be turning to 2 private sector panelists. First, we're going to be talking with Tony Hurley, who is a partner with Critical Preparedness and co-chair, actually, of the Fleet Response Working Group under the All Hazards Consortium. And Tony has a history. The history he has is being involved with big projects due to extreme weather. Things like Hurricane Sandy, for example, in 2012, and Hurricane Maria in the Virgin Islands. So, Tony, thanks so much for joining us. We're turning our attention to floods and hurricanes. We have a really special group of speakers in this session, and look forward to your comments, and please stick around so we can engage you in the question and answers. So, Tony, it's all yours.
Thank you.
Sure.
So well, my perspective is going to come from the operational perspective of floods and also surge. Over my career, I have had a number of assignments, and some of those assignments were in, mountainous terrain. Some of the assignments was in the plains where flooding could go for hundreds of acres and thousands of acres. And then also as a consultant, I've had the opportunity to assist in the Virgin Islands. I'm actually in Puerto Rico right now working. And one of the things that we do is that we encourage whatever utility or even critical infrastructure to really take a look at, their floodplain, look at their surge modeling, and find out what assets, what infrastructure is there, even from a process perspective, a supply chain perspective. As an example, we've had clients that have had warehouses that housed all their critical substation equipment, but when you did a surge report, you found out that in case of a certain type of hurricane or river flooding, that facility would be under 8 foot of water. I've had assignments where one assignment in particular that I've went to, and they've told me bring my vehicles to a particular area because of traffic and some other issues, a bridge out, we didn't get there. But the next morning when we got there, every vehicle that was in that parking lot that had been selected by the utility company, every vehicle, the only thing you could see is the boom sticking out of water. It was totally flooded because of just flood water and river and flooding. So the fact is that it's just such a critical aspect to, capture the data, look at the data, and see what it's going to do to your operations. Again, it's not just substations. It can be parts of, warehouses. It can be staging sites. Even I had a staging site that I went on Alatown assignment that when I pulled up, the staging site probably was under about 12 inches of water, and you can imagine what the mud was. So nobody was going to sleep there, nobody was going to eat there, and nobody was certainly going to park a truck there. These are all things that have to be looked at. So one of the first things we do when we come on board is we actually look for those opportunities and encourage our clients to do that surge modeling and river and modeling. I have to say that NOAA has done some fantastic work in regards to providing that information. Where you can now get in a lot of the information at your fingertips. I've often told Tom Moran that, emergency management is getting fun now because of all the data, where in the old days we didn't have access to all that data. But it's just such an important tool, and one that will keep your operation up and running. And I know it's not talked about often, but even dams. I had a client recently where we went in there and, gave them a projection that if a dam were to overflow, or even if it was, if the integrity was compromised, what it would do to his area, what substations would be flooded, what communication towers he wouldn't be able to get to if to get the generators running. It's just such an important aspect. Thanks, Dave.
Tony, thanks so much. They're really important comments. And again, those of you that are watching, please enter your questions into the Q&A. I noticed there were a couple of questions in the chat. My eyes are going more towards the Q&A, so please put them in there. They're great comments and input, Tony. I really appreciate that. Our next panelist is Richard Fimble. Richard is the Director of Emergency Management for the South Florida Water Management District. And thanks, Richard. You've certainly been busy with all these storms in the last couple of months, hurricanes. And Richard's going to give us a quick overview of the South Florida Water Management District, discuss the co-op and how their co-op, or you might pronounce it coop. We'll find out in your presentation, but how that must integrate with stakeholders and key suppliers. And then highlight some of the tools being used during blue sky and gray skies. So Richard, thanks so much for joining us. It's a pleasure to be on with you on Fridays with the telecons, and thanks for joining us here at the Resilience Exchange Summit.
Hey, thanks a lot. I really appreciate it. I appreciate everyone's time. I'm going to go ahead and share a few slides here, just sort of go over exactly what the South Florida Water Management District is, and just sort of give you an overview, because a lot of people don't have a clue, don't have any idea what we do, where we fit into the overall picture. But down in Florida, the state is basically broken up into 5 water management districts that cover the entire state. The South Florida Water Management District is, of course, down in the southern section of the state. In our area, this is our area basically. We cover 16 different counties, which is responsible for about 9 million people in this area. The South Florida Water Management District is a regional governmental agency that manages the water resources basically throughout the southern half of the state, from Orlando all the way down to the Florida Keys. We serve about a population of about 9 million people down here. We are the biggest water management district, and one in the original water management district down here in Florida that was created. Initially focused on water quality and the Everglades and a bunch of other major reservoirs and areas. But now out there making sure we're protecting the communities from flooding, meeting with the local and regional water needs, and making sure that we have enough water to go around basically. As you can see, the South Florida Water Management District covers quite a bit of area throughout South Florida, all the way from Kissimmee all the way down. A lot goes on throughout this entire area. The map as you're looking at the screen on your left-hand side, basically shows the different levees and systems that we manage and maintain throughout the entire area. We take care of the upper Kissimmee chain of lakes, Lake Kissimmee, Lake Okeechobee, and then the Caloosahatchee River, the estuary, St. Lucie River, Big Cypress, and of course, the Everglades National Park, and throughout the entire area. So it's a pretty wide area, covering a lot of different areas. The South Florida Management District, like I mentioned, covers quite 16 different counties. Our primary water control structures include about 2,175 miles of canals, about 2,100 miles of actually levees and berms that we maintain on a regular basis, over 915 water control structures, and 620 project culverts. Part of this entire system is about 89 pump stations. Now, these pump stations aren't your normal little pumps that you would go get at Lowe's or Home Depot. These pumps, the intakes can range from 10 to 12 foot in diameter. These are pretty massive pumps moving a lot of water throughout the entire area of South Florida. You have an opportunity to come down here, definitely let me know. I can definitely show you around some of these. It's pretty interesting how the system works, and it is a very well managed system throughout South Florida. So let me sort of go over basically how the overall system works. Down here in South Florida, we're extremely low and flat, which makes it a real challenge to deal with, seasonal rainfall, which can be rather intense. And then you can go into the winter where there's no rain, and we go into extreme drought conditions. And that's where you have to strike that balance to make sure that we're not flooding out communities during major events, and that we're making sure there's water to get through the dry season. Agriculture has enough water. We have a lot of sugarcane growing through here. Oranges, of course, Florida oranges down throughout here, and a lot of tourism and things like that we must be able to keep the water system and things going. If you look at the little graph, you can see the dry season there basically starts in November and goes through April. And then May through October is definitely the wet season this year. Thankfully, we got quite a bit of rain and got us out of drought mode. We had been in a period of about 3 or 4 years below normal rain, which really dried things up quite a bit, which makes it a challenge to keep things going. Our overall role basically is to monitor water conditions, open and lower gates and controls. And during after major events, route water around, try to keep it out people's homes and property and things like that. But Florida is extremely flat, which makes it a real challenge to get things moved. Our overall flood control system is set up basically in a 3-tiered system. Basically, a lot like a roadway system, where you have the interstate highway system, you got county roads, and you got local roads. And the water system starts in your local communities, with smaller drainage ponds and things like that. That initially collect water, and that water gets pushed out to the secondary canal systems. And that goes through the neighborhoods and farms and gets pushed out into the major system. It eventually gets into the major canals. That water flows through, goes into different discharge areas or major storage areas. Working through a couple of different areas now that we're able to really clean the water out after it does get some pollutants and things like that as it's coming through the system before it continues down and is either used for locals, for the local residents, or does get pushed down out to the Atlantic or to the Gulf of Mexico. It's a pretty great system. There are multiple components to the system, and all these components do need to be working together in order to make the system work and work, as it's supposed to. Because we are flat, we're on basically a knife's edge. Things can move very quickly from doing really well to all of a sudden having to deal with a lot of heavy water. Part of our system is when there are major events, we do have an emergency operations center that we do help control the flooding, control the water flow throughout the entire area of South Florida. This keeps everyone pretty busy. Since we do cover 16 different counties, we have multiple different field stations and service centers throughout the area. And of course, all that equipment that is maintained and run throughout the system. If you have a major hurricane such as Ian, which could cause some damage to different pump houses and things like that, you do have to get those systems up and going pretty quickly. Otherwise, the system will back up fairly quickly and causing problems up the line. So it must be managed throughout. We do run, like I mentioned, a full emergency operations center out of our headquarters location down in West Palm Beach, Florida. The picture you see there is our headquarters building, B1. It's one of our main structures. On the right side of the photo is the EOC building that was actually added on about 10 years ago. You see, there's no windows on the building. It's solid concrete. It's a pretty intense building. It can handle quite a few things. The canal right behind it is one of our major canals that does run from some of our storage areas out to the Atlantic Ocean and is used to push water out through the system. So we do keep an eye on that. Prior to an event, we do lower a lot of these system canals and things like that. The canal back behind us there, we lower about 3 to 4 feet. The overall depths of some of these canals in Florida, some people think they're pretty shallow. Probably pretty surprised to find out that a lot of them are about 12 to 14 feet deep, or even deeper in some areas. The EOC facility is built pretty significantly, pretty strong. The facility was built to actually withstand an F5 tornado. Yes, that's right, an F5 tornado. 205 mile an hour sustained winds and up to 230 mile an hour gusts. We have a main EOC room and overflow room, a tier 3 data center to keep everything operating. Of course, our operation control center, generators, extra fuel, UPSs. We actually have a full backup fire suppression system, water supply system, and septic system in there. This is some of our systems that we keep this up and going. Now, if we don't keep these systems up and going, it would cause a problem for the rest of 16 counties because we are able to remotely control a lot of these different pump stations, gates, and areas throughout the entire South Florida area. The EOC is, when we run operations there, is an ICS-like model. Okay, so when we go from day-to-day operations, we have normal divisions and sections. We do go into the full ICS, where you do have a full command structure, planning, operations, finance, and the different teams there. And the reporting structure is slightly different because it does go through the Director of Emergency Management for all emergency decisions and things like that as we move through an event. We use WebEOC with GIS and Teams integration, which is an extremely important part. If you're ever looking for really good maps of the South Florida area, if you come to our website, You can pull up multiple different maps through the ArcGIS system that's out there for free and available for everyone to look at and get to. Of course, we're gathering all this data to gather situational awareness, keep ahead of everything. We collaborate with our state and local partners constantly, sharing data. Our data is going back and forth with them. They know what we got going on. We back and forth. We actually have in-person liaisons sent out to all the different county EOCs as requested and to the state EOC. So we have that constant communication, which is a big part of this whole, the COOP and collaboration is keeping things up and going. Our facility here also has a full audio visual system and broadcast capabilities system here. So we can host a news media here in a full studio type setting. So we can get word out, messaging out to the public. Big thing is being able to keep that out and get information out as quickly as possible. We expedite our post-event assessment. We have several helicopters that we use on a regular basis for general operations. And I've also put together a full drone fleet, drone pilots FAA certified, and a full drone program for normal operations, but also for emergency operations to help with that immediate damage assessment and find out exactly what's going on out there. So a lot of different things going on at the same time. From a technology standpoint, we use multiple different tools, as I mentioned, to the EOC. We have several portrait screen monitors, big touch screen monitors. They're about 5 feet long, about 3 foot wide. They're great. EOC, we use thin clients. People don't have to bring in their own laptops. Like I mentioned, a lot of integration between the EOC control room and data centers. But we also have a lot of backup ability. We have microwave communications, 31 towers over the 16 counties, which can also be used and supplemented for emergency communications if our main communications systems fail here. Highly redundant communications, internet connectivity. That's key, as anyone knows, in emergency management, because if something can fail during an event, it probably will fail during an event, and we need to be prepared for whatever may happen. Our team has built out an extremely redundant system. We have multiple on-ramps basically to the internet, including wireless systems, satellite systems, of course, some microwave systems, and working through the different radio systems. These systems are backed up, and we do have these redundant systems built in at some of our major operation centers and control centers throughout the south part of Florida. So, for example, if this facility is destroyed by some other major event, that all operations are completely redundant and built up so they can be restarted at a couple of our other facilities. We have people already pre-assigned and trained to be able to take on the position. So if this building got taken out completely, including all the staff and myself, there are others that are trained and we exercise this out on a regular basis to be able to maintain operations and keep continuity of operations, which is part of the continuity of governance for the overall state. It's a pretty integrated system. It works very well. It requires everyone to work together, and it works out well. So from a COOP development, as I wrap up here, last couple of slides, big thing is making sure that, from my standpoint, because we're so large, is making sure I get a good, a THIRA, threat hazard identification and risk assessment. It's a little challenging here because I am so diverse, so widely spread throughout the entire state. I have operations center all the way up in the Orlando area. Got centers down in Fort Myers and Naples. I'm in West Palm Beach. We have facilities down in Okeechobee, Clewiston, and different areas. So it does require, a little bit of a different evaluation for each area. And that goes into the full THIRA identification. What you're doing in that is you're identifying the hazards and risks and determining the likelihood and anticipated level of impact. Basically, that chart there is a basic one that most people can find anywhere about COOP and developing your threat assessment. A lot of locations only have to do it for one facility. Like I mentioned, I do have to do it for multiple locations throughout the entire state because my threats and hazards do range considerably throughout the state. COOP development requires community and stakeholder development collaboration. Regional and local COOP plans are also pulled into it. Another area of COOP development that some people don't even think about is your main suppliers and vendors, especially your key suppliers and vendors. Now, I mentioned that we do have everything backed up. We have backed up electricity. Down here, we have 2 major generators to run these facilities. One can run it no problem. The 14-day supply of fuel, water, food, and all that kind of stuff is already built in. But 14 days, you run out of fuel. Now, out in the field, I've got pump stations throughout the entire state that could also run out of fuel after 5 to 6 days as a general area out there. So I got to make sure my fuel suppliers also have a COOP plan. Doesn't do any good if I only have a COOP plan, right? My entire network of suppliers and those around me have to have a good COOP plan too. So if you only have, for example, fuel supplier is a great one. Because if you have one key supplier, and for example, in Florida, they only get their fuel from one port, that could be a problem because the ports do close down prior to an event. And then you may not be able to get fuel, or because the different ports require different levels of security and different requirements to get in. So you need to make sure that, for example, the fuel supplier has the ability to get in not only to one port, but into multiple ports. The driver has the credentials and can get in there. Also have to be able, they need to be able to not only do intrastate work, but they may need to go outside the state to get additional fuel to keep the systems up and going. Have those rights available, be able to get into these multiple ports so that they can get things going. Got to have multiple distribution options. So something to look at. Most of us generally only think about one little part of the COOP plan. I strongly encourage you to look at those that support your COOP plan. What is their plan? Are they using the same other vendors that you're using? If so, that could be a problem. So definitely take a look at from an overall standpoint. Our COOP plan, we do update it on an annual basis. I just recently updated our COOP plan at the end of 2022. We update annually along with our CEMP, Comprehensive Emergency Management Plan. A full plan put together and building it from scratch does take a little time to develop. It's not something that you can put together in a minute or two. It usually takes, if you're starting from scratch, probably about a year to do it the right way. It requires, help from everyone to do it throughout your organization. If you're going to do something like that, I definitely make sure that you have your leadership and executive buy-in and support to do this. If not, you're going to have a significant uphill battle to get this done. So definitely work through those ahead of time. Then you start, chipping away. FEMA has some great templates for putting together different types of COOPs. Most states also have these different templates to get things together. So that's just a quick overview. I know we'll go into questions later, but if you have anything else, please feel free to ask and reach out, and I'm sure I'll be talking a little bit. Thank you. Turn back to Dave.
Thanks, Richard. Boy, that was a great overview, and I'm going to come back at the end and ask you a question related to how do you share data between your other water management districts and also the Weather Service. But we're gonna go into the last two speakers for this session, which both come from the National Weather Service, but from different but complementary centers, national centers. You may not have heard much yet. I know we talk about it on the Friday SICE calls, but you may not have heard of the National Water Center. National Water Center is in Tuscaloosa, Alabama. I've certainly mentioned them in our weekly SICE calls. But when we talk about freshwater flooding, these are the folks that jump into action. So I'd like to welcome David Valley, who is fairly recently made the transition from running the Northeast River Forecast Center, part of the U.S., to Director of Innovation and Partnerships for the National Water Center. So David, thanks so much for joining us, and appreciate you presenting to everybody, and we'll have some great questions once you and Michael are finished. So floor is yours.
All right. Thank you very much, Dave, and good afternoon, everyone. Let's see if I can get the screen share to behave itself. Let's see. Let's do this. All right. Dave, just confirm you can see my screen.
I can see it. It looks great.
Okay, excellent. Thank you very much. So good afternoon. I'm David Valley. I'm the Director of the Service Innovation and Partnership Division at the National Water Center. I'm going to talk to you briefly about the efforts that we have underway to implement innovative flood forecast and inundation mapping services nationwide. But first, a little bit about the Water Center. We are, as Dave alluded to, based on the campus of the University of Alabama in Tuscaloosa. The facility opened back in 2015. Our mission is pretty straightforward. We want to collaboratively research, develop, and deliver timely and consistent state-of-the-art national hydrologic analyses, forecast services, and impact-based decision support based on these new services and guidance that we're developing. We aren't the only ones doing this, of course. All of the services we're providing are complementary to help our field offices, the river forecast centers, and the 122 weather offices across the nation and our territories to deliver that same type of information. But for the first time in our agency's history, we now have a center dedicated to the water resource mission. I just want to very briefly show you this, our organizational chart. And what I want to illustrate for you here is the connection between our service innovation efforts, which I lead, and our analysis and prediction division. And these folks have been the ones developing the various versions of our new national water modeling capability. The interdisciplinary and science division helps us with the validation of these techniques, the methodologies, and the predictive accuracy. And then we have this geointelligence division because we realize when you're doing things at a national scale with a national water model, there is so much volume of information that what we want to do is try to visualize this and provide these services in geospatial context to help our decision makers make best use of the guidance and to allow our field offices to utilize those visualizations effectively in our briefings with our core partners. And then we have our own operations division, which now is stood up and operating 18 hours a day, providing services to some of our core partners across the nation. Now, specifically speaking about our flood inundation effort, we have been chartered to do this by an act of Congress, by the bipartisan infrastructure law, which is putting forth a tremendous amount of funding to help us accelerate over the next 5 years the implementation of inland riverine and combined riverine and coastal flood inundation forecasts. We are starting with inundation in our riverine communities, but we will be adding depth along with the aerial extent of inundation as we evolve our services. There is funding going to our center to accelerate the next generation of our national water model, which will allow us to far more effectively deal with many of the nuances in the hydrology across the country. But also, and probably as important to this community, is a complete update and completion of the Atlas 14 precipitation frequency atlas, as well as the probable maximum precipitation studies, which is so critical to the engineering industry across the United States, in the stormwater industry and so on. As part of that, we will also be introducing toward the end of the 5 years, a climate projection piece to the atlas as well. So specifically with respect to the Water Center's efforts toward the flood inundation mapping, we have been running a prototype behind the scenes, exclusively sharing it primarily with FEMA and on occasion with the Corps of Engineers, who has partnered with us, of course, to develop this capability. A lot of this effort came out of a couple of tabletop exercises that we did across the nation. 2 of those exercises occurred in Texas following Hurricane Harvey. And then 2 of those came to my neck of the woods up here in the Northeast when I was the head of the National Weather Service's Northeast River Forecast Center. So I'll speak to that momentarily. Just to let you know, if you go to our operations website for our Office of Water Prediction, we actually are now beginning to provide publicly visualizations for you to look at in this geospatial context from our national water model, as well as area hydrologic discussions and flood hazard outlooks, all of which are gleaning the discussions and information right from our new modeling capability. So we are on a 5-year march. Year 1 has completed, year 2 is underway in moving us toward the operational implementation of our flood inundation mapping forecasting effort. We will begin this effort publicly, sharing this information over our websites and in geospatial services, starting at the end of September for approximately 10% of the United States population. We will then continue in the next couple of years to move that to 30% of the nation by the end of fiscal year 24, reaching 100% of the nation, as well as parts of Alaska, Hawaii, Puerto Rico, and the Virgin Islands by the time we reach the end of fiscal year, what would be September, fiscal year of 2026. Again, we had the roots of this following the devastation of Hurricane Harvey. These are services that our partners in the emergency management community has asked the Weather Service to do for decades. And only now are we finally at a point where we have the compute power and the techniques and technology to allow us to do this and accelerate the implementation nationwide. How are we doing this? In short, we are leveraging the investments we've made to the science behind the scenes, leveraging both our River Center forecasts at 3,600 locations nationwide, as well as the new national water model capabilities, which provide stream flow forecast guidance at approximately 2.7 million river reaches nationwide. To put that in perspective, what we're doing is we're taking our river center forecast, which allow us to provide an inundation forecast at and downstream of every one of those locations, accounting to about 105,000 continuous river miles. But with the national water model implementation as complementary guidance, what this is allowing us to do is to also provide the inundation outside those known areas, accounting for over 3 million river miles, if you look at it that way, getting in a lot of the nooks and crannies across the region. Under the hood of the national water model, we are relying on the U.S. Geological Surveys, what's called the NHD, or the high resolution NHD plus, the hydrographic data set. That is what delineates each of the rivers and streams across our nation. So we are partnering with the GS and leveraging that data set to be the underpinning under the hood of the national water model. And we are applying a methodology that uses digital elevation modeling and LiDAR. It's called the height above nearest drainage method. And this is the methodology that we are perfecting and using to translate a stage or flow forecast on a river or stream, gauged or ungauged, and routing it through this technique to provide a map of the areal extent of the inundation at the peak of that particular flood wave anywhere in the country. We will be expanding prototype-wise to include Alaska in the coming year. These services are running across the nation and Hawaii and Puerto Rico as we speak, but they are prototype. We're still doing the development, but come September, we will begin to provide these services across the nation for 10% of the population. And at the end of this slide deck, you'll see where that will be come September. Now, as I said, we've been doing this behind the scenes for a couple of years, iterating on the versions and the methodology. With our first two tabletops that the West Gulf River Forecast Center and the Houston Weather Office conducted back in 2018 and 2019, emulating Harvey's passage through Texas and the Wimberley flash floods, we learned a lot of good things in the emergency management community. It wasn't that they were going to leverage these services a couple of days out in advance of a flood, but it was how they were going to leverage them and what other services they need. And here you see a great illustration of that for Texas, they're not only concerned with that aerial extent will be and who will be involved in the flood event, but they also want us to build out the depth computation, because at 1 foot they can walk in, but at 6 feet they need a boat, and God help them at 9 feet, they're going in with a helicopter. Now, when we move this exercise up into the Northeast, where I was the hydrologist in charge, I was given the wonderful opportunity to work directly with Dave and his crew at Storm Center Communications. We had the opportunity to leverage their tool, the GeoCollaborate dashboard, working in partnership, my River Center and the Water Center and Dave's crew at Storm Center Communications, working together to allow us the capability to actually do our tabletop exercises, not with a static map, but instead put in the GIS services in the hands of our partners in real time so that we could emulate the event as it happened, giving them the information we wanted them to see. But the beauty of his tool being that we were able to put in all of the critical infrastructure information that an emergency manager would want to have, basically giving him an opportunity to emulate how we want to deliver these services starting next September, both as a display, a visualized framework in our weather service web dissemination, but also allowing them to ingest the actual REST services right into their architecture in real time as the forecasts became available. So this was a tremendous learning experience for us, and it really proved the power behind the inundation services we're going to deliver. Of course, we asked the EMs, the question, when are you going to use these services? When are you going to begin to make decisions? And as we found out in Texas, the common theme was, within a 3-day time frame. That's when we'll have the confidence in your forecasts, the confidence in the expected rainfall to begin to make those critical decisions on evacuations, on securing critical infrastructure, et cetera. But you look at the power behind what we did. We in the Northeast emulated or simulated the passage of Irene through the Catskill Mountains region of Southeast New York, where there was horrible devastation following that storm in 2011. But that statement from the county emergency manager speaks volumes of the power behind what we're trying to do and what we're embarking upon. That if he had had these types of services available to him in that GIS framework, that he would have had far larger evacuation areas established earlier, would have moved critical assets out of the flood zone, pre-positioned support resources, and just overall have been able to provide better information to the impacted parts of his service area. And the last comment there about how these services in this framework are a game changer for the emergency management community. So what we envision this looking like when we begin this come the end of September for 10% of the country will be like any other GIS viewer that's there out online. You'll be able to come to our weather service site, select if you want to look at the inundation forecast based on the River Center forecast or based on the National Water Model guidance. And you'll be able to zoom into an area of interest. Here we're looking at the town of Norwich, Connecticut. We were running this again as a prototype behind the scenes during IDLE last September. And then zoom right into the neighborhood of your interest. You can type in your home address, zip it right in there, any kind of capability like you'd see through any GIS mechanism. So these are the types of services that we are aiming to begin to deliver come this September for 10% of the nation. Now, one of the reasons why we can't flip a switch and do this nationally is that we have an entire field structure to train. And the training aspect of this is quite significant for our field forecasters. They're very new to this type of capability. We need to train them and exercise them, and then work with them to go out and train their partners across their service areas. So by the end of this coming September 2023, we will be delivering these services in real time through our website and through our visualization services over parts of Eastern Texas. You see there that cluster here in the Southeast Texas area, and for a portion of the Mid-Atlantic and Northeast. The reason why we selected these areas twofold. Number one, they're hydrologically active areas, and secondly, we're benefiting from the experience of those that have been involved with these tabletop exercises. Where do we go next? Well, by the end of FY24, we're going to bridge that gap and come up the Appalachians. Puerto Rico and the Virgin Islands will come online, as well as the portion of the Pacific Northwest. And then based on the social vulnerability index and our flood frequencies, we will then continue to expand the area that we will cover, reaching 60% of the population across the US by the end of FY25, and then the entire nation, Alaska, Hawaii, Puerto Rico, et cetera, by the time we've reached the end of FY26. So Dave, I'll stop there. Be happy to answer questions as we continue along with this very entertaining session. Thank you.
David, thanks very much. This is terrific, and I hope those of you who are watching here just had a real eye opener for number one, there's a National Water Center, and number two, all the things that they're doing, and they're doing it in a geospatial approach, a way in which that those data services are going to be able to put into your systems in your operations. So we're certainly going to be keeping updated with David and the Water Center, and we'll be presenting any updates during the Friday calls that we have. So our next speaker is now a veteran of the Resilience Exchange Summit, and we thank him for returning and not being scared away. So Michael Brennan is the acting deputy director of the National Hurricane Center and is the branch chief of the Hurricane Specialist Unit at NOAA's National Hurricane Center. So I'd asked Mike to talk about the critical products that NHC puts together that go beyond that cone of uncertainty. We've all seen the cone of uncertainty, but there's a lot of other important products that the Hurricane Center forecasters put together. And so if you're looking for additional trusted hurricane products to integrate into your operations, this presentation is for you. So Mike, thanks again for participating today, and thanks to our entire panel. The floor is yours, Mike. And it doesn't look like we're hearing you if you're trying to talk, Mike.
Hey, Dave, sorry, my browser crashed at the most inopportune time possible, so I apologize for the delay.
No worries.
Let me open up my slides here and we'll get started. So yeah, thanks. It was a great session so far. And it's a great segue to go from Dave's work at the Water Center to what we're working on here at NHC. And, you know, obviously with those coastal WFOs that he talked about, we're going to be, you know, working closely with them to marry up what we're providing in terms of storm surge inundation to what the Water Center is going to provide for freshwater inundation, and try to get that to that really the holy grail of, you know, total water inundation for coastal areas and events like tropical storms and hurricanes.
And Mike, so just real quickly, sorry, we're seeing your PowerPoint slide. You might want to change your screens, maybe. We're not seeing it in presentation mode.
Oh, okay, got it. I am only in I only have a single screen up, so I'm not quite sure.
Oh, okay. Can you just, did you press the play for the,
Yeah.
can
Do
see
you
it
see
change.
anything?
No,
No,
that's okay. You can page through it. No worries.
Okay, I'll page through it. Sorry about that. There's nothing fancy on here. But what I'm going to provide today is, I should introduce myself. I'm the acting deputy director here at the National Hurricane Center. And what I'm going to provide is sort of a high level overview of the Hurricane Center's tropical cyclone products and services. And again, our role at NHC is we follow the storm from sort of the big picture perspective throughout its entire life cycle, from before genesis through development, formation, development, maturity, on through decay, and even after storms are no longer tropical cyclones. So we really cover the entire lifespan of these systems and provide sort of the big picture information about the hazards in terms of storm surge, rainfall, flooding, hazardous winds, tornadoes, surf and rip currents. And again, we're following that throughout its life cycle, and then local information is provided by the local weather forecast offices in the United States. But generally, we're trying to patch together, put together a consistent depiction of risk from the storm scale that we operate on here at NHC to the local scale and at the community level. And all that information is derived out of the NHC forecast and the products and services that fall out of that. So I'll start at the beginning at the tropical weather outlook. And I'm going to touch on a few changes that we're going to have to products this year. But the outlook is basically our product that tells you what's coming over the next 7 days, which is going to be new for 2023. We're going to talk about the potential for tropical cyclone formation out during the next week. And up till this point, it's been out to 5 days. We are making the move to 7 days now. And in the text product, you'll see a description of a potential, an area that has some potential to develop into a tropical cyclone, some area of disturbed weather. And you'll have a discussion of what we see, movement, potential for development, any sort of impacts or hazards that are ongoing. And you'll also see if the probability or the chance of that system becoming a tropical cyclone in the first 48 hours or 2 days, and then a probability of the system becoming a tropical cyclone during the next week. We are also adding the invest area number to the outlook this year, if there's one associated with that. And if you're not familiar with the term invest, it's just an area that we're tracking that's not yet a tropical cyclone, but it has a number assigned to it, AL 90 something, 91 through 99, and we just cycle through them during the season. But these invest numbers have become pretty common out there in the media and on social media, and in an effort to make sure that people know which system we're talking about, we're going to go ahead and add them to this system identifier here in the tropical weather outlook when they exist. Now, the TWO is issued every 6 hours at 2 and 8 a.m. and p.m. Eastern Daylight Time from May 15th all the way through the 30th of November. And we have the ability to issue a special outlook anytime as needed, including outside of that time period if we have something that tries to develop sometime between December 1st and May 14th. But again, this is sort of our flagship situational awareness tool for just, is there going to be the potential for a tropical cyclone to form somewhere in the basin? Now, there's a graphical component to the TWO that you may be familiar with. It's been around for many years now. We have a 2-day graphic that has a satellite image on it, and it shows you the current location of the disturbances that we're talking about in the outlook with an X. And that X is color-coded by the formation potential of that system over the next 2 days. So you can see in this example here, we have a system out in the Eastern Atlantic that has a 10% chance or a low chance of development in the next 2 days, and a system approaching the Lesser Antilles that has a medium chance, 50% of development in the next 2 days. And it also shows on the graphic the location of active systems that we're writing advisories on. And here in this example, you can see Tropical Storm Danielle here in the North Atlantic. Now, we have another graphic that this year will become a 7-day formation graphic. It used to be a 5-day, but the 7-day graphic is going to be a little different. It's going to show an X if that disturbance exists now, which they don't always do, because sometimes we're talking about, especially out to 7 days, we're going to talk about the potential for something to form that isn't there yet, primarily based on what we're seeing in model guidance. But the X and then the associated shape that you see on the 7-day graphic are going to be color coded based on the system's formation chance during that 7-day period. And the area shown by the shape is where we think that formation could occur, the potential formation area. So, for example, for this system out in the Eastern Atlantic, it has a low chance of development out through the next 7 days, and the formation area here is pretty small, only extending out to about 35 degrees west. So most of that formation chance is in the first day or the first couple of days of the period. whereas the system to the east of the Lesser Antilles, recall it had a medium chance of development over 2 days. Here it has a high chance of development over the next 7 days, with that development area extending mostly northeast of the Lesser Antilles up to north of Puerto Rico and Hispaniola and to the east of the Bahamas. And again, active cyclones are shown on this graphic as well. But this graphic is a snapshot that sort of gives you, again, that situational awareness of what's going on in the tropical, in the basin in terms of tropical cyclone formation over the next 7 days. Once we have a system that we're writing advisories on, we issue what we call an advisory package, which is a package of forecast products and graphics that are issued every 6 hours. They include a 5-day forecast of the track and the intensity of the system in terms of its maximum sustained surface winds. We forecast the size of the storm out through 72 hours. How big are the tropical storm and 50-knot winds? And then also include a forecast of the size of the hurricane force wind field through the first 48 hours. The package also includes watches and warnings for things like hurricane force winds, storm surge, tropical storm force winds, and hazard information, which is the most important information we're trying to get out there, are the watches and warnings and the hazards. Hazard information about storm surge, about rainfall, flooding, wind speed probabilities. What are your chances of seeing tropical storm and hurricane force winds? When could those winds begin at your area? And the information about tornadoes, surf, and rip currents as well. And also there's a forecast discussion, which lets you see the reasoning and confidence that the forecaster here at the Hurricane Center has in their analysis and forecast of the track, intensity, and size of the system, and any other information we want to provide about hazards, potential forecast uncertainty. And then also that contains these key messages that we've been using for the last 6 or 7 years that sort of are high-level talking points that are very hazard focused about the most important hazards associated with the storm. And on the right here, you see some of the graphics that we have associated with our advisory package. Here's an example of a storm surge watch warning in North Carolina, tropical storm force wind speed probabilities, and a key message graphic as well. Now, before I get into the more hazard specific products, I do want to say a word about the NHC forecast and the quality of them. Now, this diagram shows you on the a comparison of the track forecast error at 96 hours, or our 4-day track forecast error, and the consistency of the forecast. How much is the forecast changing from one forecast package to the next? So what you really want, where you really want to be in this diagram is in the lower left, where you have the lowest track forecast error, and also your forecasts are consistent. That means they're not changing, they're not shifting around from one cycle to the next. And that's where you see the NHC forecast. So on average, over the last 3 years in the Atlantic Basin, the NHC forecast has a lower track forecast error than the European model, the GFS, or the UK Met. And the forecast is also more consistent from cycle to cycle. And that's a huge role of the human forecaster, especially in track forecasting, is maintaining that consistency, because the models don't have any conscience and they will shift around from cycle to cycle. And if we blindly follow the model guidance around, the forecast would move around quite a bit. And that makes it makes everything change in terms of the depiction of the hazard risk. The messaging becomes more complicated. So the message here is that we're working on and making the forecast and sorting through all the model guidance, so you don't have to worry about what the next run of the GFS does or the HWRF or the European. We're taking all that into account, and we're producing a better quality product in terms of error and forecast consistency than any individual model does on its own. So let us worry about the models. Don't worry about the models. Worry about the hazards that are coming out and the hazard products and the information that's coming out of the NHC forecast. I will note too that NHC set record low track forecast errors from day 1 all the way out through day 5 in 2022, and record low intensity forecast errors out from 12 to 60 hours. We're really starting to make see some reductions for the first time ever really in intensity forecast error. And that's really exciting to see. So don't rely solely on the cone. The cone is just one product that shows you the probable path of the center of the storm. And the hazards, as we all know, extend well outside the cone, especially in the short term watch warning time frame. This is a cone graphic from Hurricane Ian that showing the forecast track and the cone across Southwest Florida, across the Florida Peninsula, and up along the southeast coast of the United States, overlaid with the initial tropical storm force wind field in orange. And you can see the huge size of the wind field associated with Ian extending well outside the cone. And the purple shows the storm surge warning area. and the pink shows the storm surge watch area. So that storm surge warning area is telling people in that area that there is the danger of life-threatening inundation from storm surge in that area, and that, you know, if you've been asked to evacuate your home, you need to follow that advice. And you can see how, for not surprisingly, for a big storm like Ian in such a sensitive area for storm surge like the southwest coast of Florida, that storm surge risk area is expansive, well away from the center of the storm, regardless of the exact track of the center. Anywhere, especially to the right of the track, is going to have tremendous storm surge risk. And you can see that was depicted here in the storm surge warning for Ian. So we really want to encourage people to look at products associated with the hazards, the watches and warnings. They mean something. They mean that there's a danger of life-threatening inundation. We're expecting hurricane conditions somewhere in the warning area. We have products that tell you the most likely and earliest reasonable time of arrival of tropical storm force winds, the chances of seeing tropical storm and hurricane conditions at a given location. We have various ways to depict storm surge risk. In addition to the watch warning, we have a new peak surge graphic that's going to be operational this year. We have an inundation graphic that shows essentially the potential storm surge inundation that could happen at any one location. And we also have the excessive rainfall outlook from our partners at the Weather Prediction Center, which is essentially a product that depicts the risk of flash flooding from rainfall associated with tropical cyclones and just in any other weather event. So I'll touch on all those here in a minute. But since storm surge drives most of the evacuation decision-making in tropical cyclones in the United States, I'll start with storm surge. And this is the potential storm surge flooding map, or the inundation graphic. And it shows a reasonable worst case scenario for inundation at a given location from storm surge. So the values you see on this map only have a 10% chance of being exceeded. And it's based on the official forecast from NHC, as well as uncertainty in the forecast of the track and the intensity and the structure of the storm. And so we run hundreds of storms through the storm surge model with varying characteristics. And we basically pick out, you know, the value that only has a 10% chance of being exceeded in terms of storm surge inundation at a given location, and that's what's depicted on this graphic. So anything you see in red has the potential for greater than 9 feet of inundation above ground level. Orange is 6 feet, yellow is 3 feet. And you saw in Dave's presentation the difference, not only in the danger posed to life and property from those varying degrees of inundation, but how that affects your rescue efforts and recovery efforts that are going on in the aftermath of a disaster like this. So the inundation graphic is issued at the same time we issue a storm surge watch, which indicates the potential for life-threatening inundation generally within the next 48 hours. And it's available within 60 to 90 minutes after the advisory release on the NHC website. We also have a peak storm surge forecast graphic, which is now going to become operational in 2023. And it's a visual representation of the storm surge numbers that we put in the tropical cyclone public advisory, sort of a high level look at expected storm surge inundation. And this is an example of the graphic from Hurricane Ian last year. And you can see that it helps you highlight the areas that have the highest risk of storm surge inundation. And the first thing that jumps out here is this area from Inglewood down to Bonita Beach, with a potential for 12 to 16 feet of inundation above ground level. And this product means that 12 to 16 feet is expected somewhere between those 2 points along the immediate coast. And you can see the other depictions of storm surge values that are expected. So from the middle of Longboat Key up to Anklet River, 4 to 6 feet expected somewhere in that area, and along the East Coast as well. And this is going to be different potentially from the inundation graphic, since that's a location-specific reasonable worst-case scenario. And this is showing you an expected value that's expected to occur somewhere within the indicated area, not everywhere. Then I'll move on to the wind risk. And we have wind speed probability products that tell you the location-specific probabilities of seeing sustained tropical storm force winds, 34 knots, strong tropical storm force winds are 50 knots, and hurricane force winds is 64 knots. And these products account, again, for the official NHC forecast and typical uncertainty in the forecast track and the intensity and size of the storm. And these are available in both graphical format and in a text format on our website, also in GIS format. I'll touch on that a little bit at the end. But this gives you essentially the probability of tropical storm or hurricane force winds occurring at your given location based on the forecast and the typical forecast uncertainty. Also falling out of those wind speed probabilities are information about the time of arrival of sustained tropical storm force winds, which is a huge decision point and a decision, a pivot point in evacuation, decision making, other preparedness activities. Generally, everybody wants to have those activities completed by the time tropical storm force winds arrive at a given location. This graphic provides you, or graphics provide you, an earliest reasonable arrival time, which is the most conservative timing. It's only a 10% chance that the winds would start before that time, and a most likely time of arrival, which is sort of the middle of the timing distribution. But again, it's accounting for that uncertainty in the track, intensity, and size of the storm, and gives you a range of when those tropical storm force winds could start. And for Laura here, if you're looking at Southeast Louisiana, you see the range of the arrival time of the tropical storm force winds is about 12 hours long. So the winds are most likely to start Wednesday morning, but they could start as early as Tuesday evening. If the storm moves faster, if the storm gets bigger, if the storm moves closer to that given location. So there's a lot of information in here that can be helpful for planning and decision-making purposes. Now I'll touch on the WPC excessive rainfall outlook, which is a risk-based product that looks at rainfall rates, total rainfall, flash flood guidance. What's the potential for flash flooding at a given location? Where is the greatest risk? It's a situational awareness and planning tool. And this is the excessive rainfall outlook that was issued during Hurricane Ida, or after Ida made landfall and was moving up through the mid-Atlantic states. And you see this high risk area here extending across much of southern and eastern Pennsylvania, up to the New York City metro area and into southern New England. And this was the area that received that catastrophic flash flooding. So these, when you see moderate or especially high risk areas in the ERO, that should be a flashing red light that there is significant potential for not just flash flooding, but life-threatening flash flooding and very potentially economically damaging flash flooding, especially at those high-risk areas that are often associated with heavy rainfall from tropical cyclones and their remnants. Finally, I'll touch on the GIS products. If you go to hurricanes.gov/GIS, we have a variety of our products available in KMZ and shapefile format for ingest into your display systems. It lets you look and slice and dice the information in a lot of different ways. This includes all the storm surge products. The peak storm surge graphic, as it becomes operational this year, will be available in GIS format. The inundation graphic, storm surge watch warning, the wind speed probabilities, the time of arrival products, all of that information is available in GIS format. So I'll wrap it up there and look forward to the discussion and glad to take any questions or comments. So thanks, everybody.
That sounds great, Mike. I really appreciate that. And hopefully those of you that are watching are thinking about how you can use these products in your operations. You might see them. And one of the biggest points that I think that Mike made is listen to the official National Hurricane Center forecast on where the storm is expected to go and how intense it's expected to be. And don't pay attention to things you might pull off the internet of just one forecast time being shared by a particular model. That is not how you should operate any emergency operations centers or make any long-term decisions. So I did just want to turn to a question that we had here and one that I had as well. Mike, when you talk about a storm that's about to make landfall, and David, you talked about modeling inundation and floods from the freshwater part of the storm. I'm just wondering for our audience here watching, what will happen at that interface where the ocean salt water touches the freshwater, and you might get issues of, water backing up from the freshwater because the storm surge is coming in, or, how could these kind of models and forecasts that the National Water Center is going to make and the National Hurricane Center is going to make impact somebody like Richard Fimble, who is in charge of the South Florida Water Management District? We can start with Mike first and then David. I'm not hearing you, Mike, if you're talking. It looks like you're muted. While Mike's figuring out the mute, or maybe he can't hear me, let's turn to David. David, you can start with there. Yeah.
Sure. So yeah, this is going to be something we're going to continue to work on collaboratively. Our approach right now is that we're going to have a separate modeling routine running in the national water model that's going to bridge this gap where the riverine ends and where that tidal reach of all of these rivers and streams begins. And the general geography will be from an elevation of about 30 feet or 10 meters inland to a depth offshore of about 5 meters or 30 feet of depth. That's going to be the boundary by which we're going to be doing a separate bit of forecasting and modeling of that interaction. We're going to be driving that boundary with the Hurricane Center's 10% worst case scenario surge guidance that they're providing publicly today. So that's going to be the tidal boundary condition whenever we have a named tropical cyclone or a cyclone potentially to become tropical where the Hurricane Center is generating the storm surge guidance. During the rest of the year, we're going to leverage the STOFs, which is the NOS's storm and tide operational forecast system as our boundary condition for the tidal component. The National Water Model will be providing the riverine boundary, and then we're using a model called SCISM, which will actually do the computations in that reach. And then from that, the National Water Center will derive its riverine FIM, the flood inundation mapping, using that calculation to define the areal extent and eventually the depth. And then probably a year or so from now, we hope to begin to provide an experimental product that will be complementary to the Hurricane Centers, where we'll be showing what that coastal inundation will look like with that riverine response. But this is going to take a couple of years for us to evolve. It's not even an experimental framework yet. We're still doing the testing. The version of the National Water Model that will contain this capability and computation is about to go through its first science evaluation, 30-day science evaluation coming up in the middle of February. So we've still got a couple of steps to go. But it's an exciting capability, and as Mike said, this is kind of like the holy grail for us to really now be able to provide a true computation and estimate of what that inundation could look like when we've got a significant riverine contribution coming into the tidal estuary.
Mike, I see you back online. Go ahead if you want to chime in there.
Yeah, no, I think Dave covered it. Apologies for more technical issues here, but yeah, I think Dave got the details right. We're going to couple up what we're providing from P-surge, the probabilistic storm surge, to the National Water Model, and we're in the process of looking at validation of how that's worked in previous cases now, and that'll inform how we make this the most comprehensive and accurate product we can make it going forward. But as Dave mentioned, the ability to, you think of a Florence example where you had catastrophic storm surge and catastrophic riverine flooding, essentially commingling in the same area in time and space, and to be able to provide a comprehensive and complete picture of that inundation is really a key thing for emergency managers and other decision makers, across the enterprise.
And Dave, as we begin to develop our visualizations, where we have the benefit of what Michael and the Hurricane Center has done for a couple of years with their products on how should the visualization appear, utilizing this social science and the research that's been done with our partners to make sure that we're providing it and conveying it in a way that's meaningful and useful to them and not in a confusing fashion.
Well, that sounds great. I really am encouraged by that progress. And Tony, I'm wondering if you're still online with us, Tony Hurley. I had a question for you in your consulting business and also for what you experienced when you were with the utility. What's the most vulnerable situation that you think utilities, power sectors, are in when it comes to extreme events, whether they're climate related like drought and heat or hurricane related? What's the vulnerability that they're really trying to address right now?
Every weather event has its own level of dangers. I don't think there's a utility person out there that can, wouldn't tell you that an ice event is just something that's miserable. You work all day and then the ice brings it right back down. Hurricanes can be so unpredictable because the saturation prior to the wind makes all the difference in the world. The hurricane comes in, you're going to get some damage. But if you had, unusual weather a week before where the ground is saturated, it's even going to be worse. So the worst situation is just not planning. FEMA recognizes 18 different weather events. And what I've seen individuals just overlook something, like overlook river and flooding, and the data's there. And I have a lot of clients that are surprised sometimes when you come in and say, what is your plan for these 4 assets that are in this water zone? And many of them don't realize they even had a situation. I had somebody who their backup EOC was in a water zone. So the fact is, it's just not thinking through and not planning. And I know there was a question there about who do you involve in a co-op? It's everybody. You have to really just engage everybody, look at what's failed in the past and engage everybody in this. And when you're talking about how do you sell it, especially in tight budgets, you show people the consequences. You show people that, yes, it's going to cost us $200,000 to do all this, but it's going to cost us millions if the event happens and we're not prepared.
Yeah, no, that's terrific. I appreciate that. And we are running late with this session just because we had questions to ask, and this information is so critical. There are a lot of other questions as well, but we do need to move on. I appreciate our entire panel, Michael, David, Richard, Tony. Flooding and hurricanes impose major impacts to our critical infrastructure.